Hello, everyone. Welcome to review day 2. I'm kind of hoping that before you watch this video that you've worked through the problems on this sheet just to see what you can do on your own, and that you're more or less using this video as a way to kind of go back and review the problems that you didn't know how to do. So you can kind of use this like a video key to this review day assignment that I built here. All right. You should also be working through the practice problems that are on MyOpenMath. That way you can get the instant feedback from MyOpenMath, see if you're doing those right or wrong. And if you're getting the green check mark, great. If you're getting the red X, well, that's a sign like you need to be asking questions or consulting this video. All right, so let's jump right into it here. We haven't seen this problem since the beginning of chapter 8. Our goal here is to take a look at the graph and see if we can determine a possible equation. All right, so they give us a couple of clues in the direction. So if you read carefully here, they tell us that this is a sixth degree polynomial, which means we will have 6 of those linear factors. They also want us to write our equation in factored form. That's a key piece of information there. So when we talk about factored form, that means we want something that looks like this, with the linear factors. And since it's a 6th degree, we should have 6 of these linear factors. The other thing they tell us is that the leading coefficient is 1. That means the number out front of the parentheses is going to be a 1. Okay, so we've got a lot of stuff to help us out there just by reading the directions. All right, so now we can actually jump into the graph here, and to be able to write these linear factors to get into that factored form, we need to know the roots and the x-intercepts. Okay, so when we talk about roots and x-intercepts, they're practically the same thing. It's just a difference in how they are written. They're both representing numbers that make the polynomial be 0 on the y scale, right? So when we look at the y scale, right, this is y, this is x, we're looking at the y scale, we want to be 0, so that's down here. So anything on this line where the graph crosses this line, that is where a root or an x-intercept is going to exist. And beware, when you get a graph that looks like this, it has this weird little thing going on here. It's just a graphing mishap. It's just the graph can't get precise enough, but that is touching the x-axis. So this would be one of our x-intercepts here. We have another x-intercept here and another one here. So we can see 3 visible x-intercepts. All right, so if I'm writing it as an intercept, we want to write it as a coordinate. So this will be -3, 0. That would represent this x-intercept here. And then we have another one located here. So this one's going to be -1, 0. Okay. And then this one is going to be at 1, 0. All right. So those are written as x-intercepts. Now, when we write them as roots, we really don't care about the coordinates. We just really care about this value here in the x-coordinate part of the coordinate. All right. So I'm going to go back here and I'm just going to list the roots. We're going to say -3, -1, and 1. Okay, so we've got 3 distinct roots, but remember they did say this was a 6th degree polynomial. All right, so real quick, just before we move on, let's talk about the end behavior real quick. So remember, the end behaviors are the ends of the polynomial. So as I go off to the left, what is this thing doing on the very end? So that would be this piece right here. And then the same thing as we go off to the right, what's it doing on the far right side? Is it going up or down? And so we're looking at this piece right here. So this one is going up, up. Okay, so we're going up and up, right? So that's how we've been describing end behavior so far this year. And you want to be able to do that from a graph. It would be handy to be able to do on the test. All right, so let's get into factored form. All right, so we've got y equals, and we can write a factor, right? If we know the roots, we can write a factor. So there is this relationship between the roots and the factor. So if I have a root of -3, we're going to have a factor of x plus 3. And that is because if I take this -3 and I plug it in for x, I get -3 plus 3, which is 0. All right, so that's going to be one of our factors. We're going to have another factor for the -1. Using that same relationship, I can just say, well, we've got a factor of x plus 1. And then same thing for the last one here. Since we have a positive 1, we're going to have a factor of x minus 1. Again, we keep on glossing over this fact, like we should have 6 factors. They said it was a 6th degree polynomial, so where's the other 3 factors coming from? Well, let's take a look at our roots here. So notice at the -3, this is one of those bouncing situations. We call this a bounce, okay? So we have to pay attention to the behaviors that are happening at the individual roots. when we have a bounds that indicates that this is a double root. That means that the -3 actually happens twice, which means this factor that we created here needs to be squared. There's actually two of them. So we're going to have x plus 3 twice. And now if I count up my linear factors, I have 2, 3, 4. So I'm up to a fourth degree polynomial. All right. So now when we look at this 0 here, there is no weird behaviors going on. It just passes through without any incident. So that just tells me it's a single root. There's nothing to be had there. But then I come over here to this one, and I notice it has that little inflection, right? So as it passes through the 1, it flattens out and then passes through. Okay, so when we see that flattening thing, we call that an inflection, and that indicates a triple root. Okay, so this is a triple, which means this factor needs to be raised to the third power because there's actually 3 of them. Right, so there's actually x minus 1 times x minus 1 times x minus 1 3 times, but we can shorten that up with an exponent. Now if I add up my linear factors, I have 1, 2, 3, 4, 5, 6, completing my 6th degree polynomial. All right, so it's important to find your roots, look at the behavior at each root to see if there's any doubles or triples, and then write your factored form based on that information from the graph. All right, let's move on to our next problem here. So this is very similar to what we just did. The only difference is they did not give us a graph for these x-intercepts. They just straight told us the x-intercepts are at these locations, okay? So just based on what we did in our last problem, I can instantly say, well, the roots are 1, 4, -3, and 2, right? Because we are grabbing the x-coordinates of those x-intercepts from each of those points. So these are our roots since they tell us in the coordinate that those all make zeros, okay? So they do want the polynomial to be in factored form, and they tell us the leading coefficient is going to be a +1. All right, so I'm going to set up my polynomial here. So there's my 1. And then I'm going to set up some factors, right, because I have my roots. So if I have a root of +1, we must have a factor of x minus 1. +4 makes a factor of x minus 4. -3 makes a factor of x plus 3. And then +2 makes a factor of x minus 2. And there we go. We are in factored form with a leading coefficient of +1. As far as double and triple roots, we would call this a possible equation, but without being able to see the graph of this thing, I really can't determine if these are double or triple roots or not. There's no way to tell unless they specifically tell us, or we can see the graph and we can look at that behavior at each of those roots. So this is good enough, right? If this is all the information they give us and they don't let us see the graph, then this is really all we can do. Okay, so let's try another one. So very similar, it's just, again, that wording, they give us the roots this time. So they gave us the x-intercepts before, right? So they're telling us the roots are -10 and 5, right? So if I'm writing the x-intercepts here, then I know I've got -10, 0, and an x-intercept of 5, 0. And they want us to write a polynomial function in standard form. This one's a little bit different. They do not want factored form. They want that standard form. And remember, standard form looks like this. So y equals, ax squared plus bx plus c, right? Where everything's being added and subtracted, so no parentheses. Okay, we can handle that, all right? But we're going to start with factored form. That's usually the easiest way to do this. We start in factored form, and then we can go from factored form to standard form. So if I have a root of -10, I'm going to have a factor of x plus 10, and then I'm going to have another factor of x minus 5. And then to get into standard form, I'm going to multiply those out. So I'm going to set up a box, kind of like this. And I'm going to go 2 by 2 because I'm looking at my two factors, right? If I look at these, I have an x and a 10, and then here I have an x and a -5. So I have two things in each of those factors, so I need a 2 by 2 box. So we need our x plus 10 there and our x minus 5 up here, and then I'm going to go through and multiply. So let's see, so we got x times x, well that's x squared, x times -5, that's -5x, x times 10, that's 10x, and then 10 times -5 is -50. Then we got to add up our 4 boxes, right? So I'm going to say y equals x squared minus 5x plus 10x minus 50. All right, so I just wrote it out as a big sum, and then I'm going to combine like terms. So again, like terms are those things that have the same variable raised to the same power. So that'd be these two things right here, negative 5x and a 10x. They both have an x. Okay. This one is an x squared, so it's not the same, right? But these two I can combine. Here we go. Let's write it out. Y equals x squared. Negative 5 plus 10, well, that's going to be a positive 5x minus 50. And there we go. There is our polynomial in standard form, and it contains these two roots. And if you're not sure, if you wrote a polynomial and you're like, I think this is the right answer, graph it and go look at your x-intercepts, right? Make sure it's got these two x-intercepts. That'll tell you if you got it right or wrong. Okay, so use the graph to your advantage there. All right. Also, make sure you pay attention to the wording. I almost missed that myself when I read it. It said in standard form, not in factored form, right? So up here, and I circled that factored form. Let's make sure I get my polynomial in the form that they want. Okay, so let's try another one. All right, so again, let's make sure we read carefully polynomial function in standard form. So again, we just talked about what standard form looks like. We have these roots. So these are complex roots, not a problem, and they want us to use x for the variable. All right, so let's just list out what we know. We know the roots are 6i and negative 6i, which means the x-intercepts are none, right? These are not real numbers, right? So they would not appear on a graph at all. So these are complex numbers, right? Complex roots. So we're not going to see any x-intercepts on the graph. So when we're done and I look at the polynomial that I create, if I see x-intercepts, then I did something wrong. All right, so it's just another clue, another layer of being able to check myself. All right, but we can write the factors still, right? So if I have a root of 6i, I must have a factor of negative or x minus 6i. If I have a factor or a root of negative 6i, then I must have a factor of x plus 6i. Okay, so right now I have an equation in factored form, but we want to get into standard form. So I'm going to draw a box just like I did in the last problem. All right, so really the process is no different than what it was before. It's just we have complex numbers, right? But the process stays the same, right? Everything we knew before still applies. All right, so x times x, well, that's x squared. X times 6i is 6ix. I know that confuses students right there, but there's really nothing you can do. It's just a multiplication. You have three things. There's nothing that simplifies, so 6ix is correct. We'll get negative 6ix here in the bottom left-hand box. And then we multiply negative 6i times 6i. Well, that's going to be negative 36i squared, right? Because I times I is I squared. Then we write it out, right? Try and add everything together. So we've got y equals x squared plus 6ix minus 6ix minus 36i squared. Okay. And same thing as before. Look for your like terms. We have 6ix and negative 6ix. Those are the same. They have the same variables raised to the same power. All right. This one has an x squared. Nothing else has an x squared. So this cannot be a like term with anything else. This over here has an I squared. Well, that's not a like term with anything else. Nothing else has an I squared. So we're going to move forward with just combining these two. And when we have a positive 6 and a negative 6 and we add that together, these are going to cancel out, become 0. So we get x squared minus 36i squared. Okay. We're almost done, but remember I told you way back in the beginning of the unit, if you ever see an I squared, you have to simplify it. Okay. So remember, I squared is negative 1. We talked about that at the beginning of the unit. So we're going to have x squared minus 36 times negative 1. I replace the I squared with the negative 1 there. And then when I multiply, since it's a negative times a negative, we just get y equals x squared plus 36. There's our standard form. Okay. This is what they're looking for on that problem. All right. Let's try it again. We got one last problem here to talk about. This one says solve the quadratic equation and find the roots. Okay, so essentially when we find roots, right, we're trying to find a value of x that makes a 0. And that makes sense here because it's set equal to 0. So I'm trying to find a value of x such that if I were to plug this value of x in, I would get a 0 out. Okay. They gave us a quadratic formula here that's usually assigned like, hey, this quadratic formula thing might be handy in finding what it is I'm supposed to find, since we're supposed to find the roots here. So I'm going to use this. I'm going to find my A, my B, and my C value here. So remember, A is the value in front of x squared, so that's just a 1 if we don't see anything. B is going to be 8, that's the value in front of x, and 65 is the constant on the end. And I'm going to plug those A, B, and C values into the appropriate location here with the quadratic formula. So we've got x equals, and then -8 plus or minus square root b squared, so that's going to be 8 squared, minus 4 times 1 times 65. All right, so 4 times A times C. That's where those numbers came from. All over 2A, so we got 2 times 1. And there's our setup. So now it's just a matter of taking our time, do one thing at a time. Don't try and type this into a calculator. You'll probably make a mistake. All right, and so all that advice that I've been giving you before, take it now. All right, this is a test, so take your time, get it right. Okay, -8, not changing, it's staying the way it is. 8 squared, that's 64. 4 times 1 times 65. Sometimes with those bigger numbers, you need to get out a calculator. Like I said, I don't mind you using a calculator on this. Just don't try and type in the whole thing at once. I see so many kids do that, and it never works out. Let's see, we got 4 times 1 times 65. There we go, we got 260. Okay, so minus 260. That's just multiplying those three. And then in the bottom there, 2 times 1 is just 2. Okay, so then we go next line. So we can do the 64 minus 260. So I've got -8 plus or minus, get my calculator back out here. So we got 64 minus 260. We got -196 over 2. So it's getting easier, right? Every time I do something, it gets a little bit more manageable. So let's take care of this thing. So again, notice we're square rooting a negative. The negative is inside of the square root. So I'm going to go over here and I'm going to handle that. I'm going to put that into its complex form. All right, so we've got the square root of -1 times the square root of 196. This is going to be I. That's where our I comes from. And then the square root of 196. Text. Check that in a minute. Yeah, 14. All right, so I times 14 is 14i. All right, so I'm going to have -8 plus or minus 14i over 2. All right, so we're getting there. We got some complex roots. It's not a big deal. All right, we know how to handle that. It's a simple step right there. And then remember what I told you about this problem. If both of these numbers in the top are divisible by the number in the bottom, go ahead and divide them. 8 and 14 are both divisible by 2. So if I do -8 divided by 2, I get -4 plus or minus, and then 14 divided by 2 is 7, so that'll just be 7i. All right. Now in my open math, when you enter this in, okay, this is going to be -4 plus 7i, comma, -4 minus 7i. That's how they want the answer entered in. That's really what the plus minus means. It's both of these expressions written as one. It just makes it a little bit easier to write, but my open math can't differentiate when you use a plus minus. All right, so you got to make sure you enter in both of your answers separated with a comma. All right, guys, that's it for review day 2. Hopefully you found the video helpful. If you have any questions, make sure you let me know in the Zoom chat. Have a great day.